Good afternoon, everyone. We're going to go ahead and start into our unit on periodic tables. And basically, our unit on periodic table is going to teach us how to use the periodic table to get information. Now, of course, our essential question, this is going to be our essential question for the entire unit. How can I use the periodic table to explain the properties of an element based on its position? We're going to look at where it's located, what group it's a part of, what family it's a part of, and use that information to figure out the properties and characteristics, and even how we'll be able to use that later on throughout the year. Now, learning goal for our first video is going to be students will be able to use basic properties to distinguish between the three main types of elements. We started talking about these a little bit before, and this is why I had you color your periodic table. Now, as saying before, we're going to use our periodic table, and this is just going to give us a little bit more properties of our three main types of elements. So, follow along in your notes, make sure you fill in the information, and I believe for just about everything in here that you'll be filling in, it is underlined and bold, so it makes it much easier for you guys to follow along. So, let's get started. Now, in 1869, Dmitry Ivanovich Mendeleev created the first accepted version of the periodic table. Now, his periodic table is arranged in terms of atomic mass. And this made perfect sense to him because if you were looking at the overall mass, you saw a trend or a pattern that was emerging. Now, as he did this, he found that within the different families and the different groups that he put them in, they also had very similar chemical properties. He even left spaces where he would be able to add in some other elements if they were found. Now, this is what his periodic table looked like, and you see that there are some spaces just around here, here, here. Now, over time, they actually found the elements that would fit into those spaces, so Mendeleev was actually on the right path. But as time went on, we found that there should have been a little bit better way to find it. Now, the periodic table itself organized the elements in a particular way, and we can use this to find out a great deal of information just by looking at the position. We can find out physical properties, chemical properties, and even take a little bit of time to understand how they react and how they respond to certain situations. These are some common elements, and I put these on here because these are common ones that a lot of people mess up, just because either the symbol doesn't look exactly like the name or little things here and there. But again, you have your periodic table in front of you. You'll be able to find a lot of these and just get used to messing around with them and learning from them. Now, the elements on the periodic table can be divided into three main categories: metals, nonmetals, and metalloids. Same way that you colored them on your periodic table. Some of the properties that we're going to use of metals are that they're good conductors of heat and electricity, that they're shiny, that they're ductile, which means they can be stretched into wires, they're malleable, which means they can be pounded into thin sheets, and that many times they'll undergo corrosion. If you've ever looked at a car battery and you get that stuff that builds up on the terminal, that's corrosion. That's where it's reacted with acid and started to break down. Now, another little note that you're going to have in here is that metals also lose electrons in order to form ions. This is going to be something that we're going to use later on in our bonding unit. So you want to put it like a little star right next to that. Sorry, my star looks a little strange. But moving on. The next part that we're going to go to is our nonmetals. Now, these nonmetals are going to be poor conductors of electricity and heat. Most of them being gases. That makes perfect sense. Now, the other thing that we're going to look at is that they are not malleable or ductile. We can't beat them. Many of them are actually brittle and they'll break away very, very easily. So if we try to pull them or beat them, they just break into dust. Now, nonmetals are the opposite of what we had for metals. Sorry guys, my wife is cracking little jokes here. Instead of losing electrons to form ions, nonmetals are actually going to gain electrons. So again, another one of those little things where we're going to put a star next to gain electrons in order to form ions. And this is one example we have here next to us, which is sulfur. We've smelled it. It has a very horrible smell to it. Now, the last group that we're going to talk about here is we're going to talk about our metalloids are going to be metal-like in that they have properties of both metals and nonmetals. These can be either shiny or dull. They conduct heat and electricity better than nonmetals, but not as well as metals. And they are ductile and malleable. Now, for metalloids, they're going to be very, very important because most of us have these electronics. We have computers, cell phones, televisions, all the circuitry and everything that is used to make up the electronics of these substances is usually a nonmetal or are made of nonmetals. Now, elements in the periodic table are also grouped into families, groups or families, which are going to be the columns, and they have similar properties to each other. The other way that we're going to look at it is they'll also be grouped in terms of periods or horizontal rows. These will not have similar properties at all. So we'll talk about that just a little bit more right here. Now, the first statement we just talked about, columns of elements are called groups of elements or groups or families. Elements in this have similar but not identical properties. For example, if you remember back to the video that I showed in class, or if I haven't, I'll show it on tomorrow. When we look at things like lithium, sodium, potassium, these are all in the group 1A family. And these are all soft, white, shiny metals. Now, all the elements in a family tend to have the same number of valence electrons. That's going to be the electrons on the outermost shell. We'll talk about that outermost energy level or shell a little bit later. But it's very important as we look towards bonding that we start to see how these valence electrons sort of play a role in how our bonding will take place and how the elements will respond. Now, the periods, the horizontal rows are going to be called periods. These elements are not alike in any way. Or do not have to be alike, I'll say. Now, in fact, they're going to change greatly across the row. What do I mean? Well, the first element in the period is always going to be an extremely reactive solid, a metal, one of our group A metals, whereas the last element in the period is always going to be an inactive gas. These are our noble gases, which we'll get to a little bit later. But as we look at this information, we start to see that we can have these varying properties across the entire periodic table, yet they somehow still fit together. Now, there's more than one way that we're actually going to use to categorize and to organize this information. Take some time, look over your notes, because in our next video, we're going to actually start to look at the individual families and find the properties of those groups. Have a great afternoon, and I look forward to seeing you in class tomorrow. Goodbye.